Hello everyone and welcome back. I hope you had a good spring break. So this is going to be the first online lecture that we do for the rest of the semester. Today's date is the 23rd of March. Okay. And today we're going to talk about section section 1.5, which is about solving equations by factoring. Okay, so we've already seen some of this. Last time we talked about solving quadratic equations by factoring. Remember, quadratic equations are equations that take this form here. Okay, ax squared plus bx plus c. Okay, so for example today, in this section they might ask you to solve x cubed plus 3x squared equals 4x plus 12. Okay, so this is not a quadratic equation because, see, here we have a term that has an exponent that's higher than 2. So x cubed makes this x cubed term makes this a non-quadratic equation. Okay, but the idea is still the same. So we're gonna in section 1.3 when we talked about solving quadratic equations by factoring, we used the property that if a times b equals 0, then either a or b equals 0. Okay, so we're going to still use this idea. So the first step is to take this equation and get a 0 on one side so we can use this property. Okay, so you could either subtract these two terms over to the other side, or you can subtract the 4x and the 12 over to the other side. So that's what I'm going to do. So it's, instead of x cubed plus 3x squared equals 4x plus 12, we're going to have x cubed plus 3x squared minus 4x minus 12 is equal to 0. Okay. So we did learn a technique for factoring non-quadratic equations back in the review chapter. So in this case, we can actually factor this equation here. We can factor it by grouping. Okay, so if I group these first two terms together, plus negative 4x minus 12 equals 0, we can factor out an x squared from both of these terms. So x squared times, so if we factor out an x squared here, we're left with an x, and then this one we're left with a 3. Okay, so for the second term, each term has a negative 1 in it, so we can take that out, and then 4 is divisible by 4, and then 12 divided by 4 is 3, so we're going to factor out a negative 4 here. So instead of a plus here, we're going to get minus 4 times x plus 3. So yeah, a common mistake is that some people might leave this as a minus sign here, but you have to remember that you're factoring out the -4 from both of these terms. Okay, so now we can factor, we have two separate terms here, one term, another term here, and they both have an x plus 3 here, so we can factor that out. So if we factor it out from the first term, all we're left over with is x squared. If we factor it out from the last term, we're left with -4, and then we have x plus 3 equals 0. Right, so a good way to check if what you're doing is right is you should always be able to go backwards, right? So if I just distributed this x plus 3 to both of these terms, I get right back to where I was here. Okay, so it kind of looks like we're done here, but we're not quite done because we can still, this term here is still, it's not an irreducible term. This one is, but this one is not. Okay, so x squared minus 4, so you can use our special property a squared minus b squared equals a plus b times a minus b, or you can think of two numbers that multiply to -4 but then again add up to 0, right? Because when you're factoring a quadratic, you want to look for, and then your coefficient in front of the x squared term is 1, you can look for factors of the last term that add up to the middle term, and the middle term here is 0. Okay, so this one here is going to factor into x plus 2 and x minus 2. And then we still have this x plus 3 left over. Okay, so these are three irreducible terms. Okay, so same thing, if it's a times b equals 0, we can also do a times b times c equals 0, right? So the only reason I'm throwing in the a times b times c equals 0 is because we have three terms here, and that goes on for as many terms as you want. So we can solve each one of these separately because of this property here. Now, if this right-hand side was not 0, we wouldn't be able to do that. So that's why the first step here of getting everything, making a 0 on one side is important. Okay, so we have to solve. Sorry, solve x plus 2 equals 0, x minus 2 equals 0, and x plus 3 equals 0. Okay, so for this one, we would subtract 2 from both sides, so then we get x equals minus 2. So for this one, do the opposite, you add 2 to both sides. And for this one, we would subtract 3 from both sides. Okay, so here are your three solutions. Okay, and because our original equation here, this is a degree 3 polynomial here, so we might expect that you might get 3 different solutions. Okay, so just like when we were talking about quadratics, you can get either 0 solution, no real solutions, one solution that's kind of a double, right? Or 2 separate solutions. So in this case, we got 3 separate solutions. Okay.